This is Athota Rathan Babu, working as an assistant professor in the Department of Aeronautical Engineering, and I'm dealing with the course Computational Aerodynamics. In today's topic, we will see alternating direction implicit method. So basically, we'll say what is alternating direction implicit method. So and how it is helpful for solving CFD problems. We will see in detail. So previously we have seen the difference between explicit and implicit method. So let us recall. So basically what is explicit and implicit, and we will see it how this is involved in alternating direction implicit method. So let us take the diffusion equation. So dou u by dou t plus alpha dou square u by dou x square is equal to 0. So this is what we have for the diffusion equation. So this one let us see in explicit and implicit method, and let us do it for the ADA technique. So why? Because so for alternating direction implicit method, so both explicit and implicit methods are must and should, and we will be using those two things alternately. That's why as a prerequisite, so we need to know so what is explicit method and implicit method, so which we have discussed in the previous classes, but let's recall once again. So we'll see what is explicit actually. So in the explicit, so how do we discretize this diffusion equation? We will see. So let us take it as equation 1. So this one, so u of I, so simply 1D. So basically we will take it as u of I to the power of n plus 1 minus u of I to the power of n. So divided by delta t plus alpha into so u of I plus 1 to the power of n minus 2 u of I to the power of n plus u of I minus 1 to the power of n divided by delta x square is equal to 0. So let us take this as 2. Okay. So here you can see that equation 2. So what are the terms we have? So subscript I. So this subscript I indicates the index notation. So basically this is for x direction. Okay. And the superscript n. So basically this n indicates the time level. So basically n will start, let us take it as 1 second, 2 second, 3 second, 4 second, 5 second, so on, n seconds actually. So the n value will vary in this way. Basically this is the time, okay, which is taken in terms of seconds. So index I notation, so basically it will vary with respect to grid points. So if we recall it again, so let us take a simple mesh. Okay, simple mesh quantity. So here let us take this as I. So this point would be I plus 1. So this point would be I minus 1. Okay, so this is what we have for I. So basically I will start from 1, 2, 3, 4, 5, 6, 7. So on till the n, or you can take how many number of grid points we have. So basically here index I is indicating the location of the grid point, and index n indicating the time level actually. Fine. So if n is equal to 1, let us take what happens. So let us take for example, so what happens when n is equal to 1 we have, and I is equal to 1. Let us rewrite actually. So what happens? U of 1 to the power of 2 minus u of 1 to the power of 1 divided by so delta t. So basically what is delta t is, let's say, time step whatever we have taken, so between t1. So basically delta t is nothing but so it is t2 minus t1. So if we take t1 as 1 second and t2 as 2 seconds, so basically delta t will be as 1. So basically therefore u1 to the power of 2 minus u1 to the power of 1 divided by 1. So basically this will be the same term which we have is equal to so minus alpha. So the diffusion term we have into so delta x. So basically delta x is nothing but So the distance between two grid points. So here we have, this is delta x and this is delta x. So if we have the sizing or the spacing between the two grid points same, so the delta x will be equal at all the intervals. If it is not same, so basically it is called non-uniform mesh and the delta x will differ. Okay. So let us consider it as a uniform mesh. So delta x, let us take it as 1. Okay. So or let us take it as 1 mm, or you can take 1 centimeter, but you have to convert into standard units, which is 1 meter. So for assumption, so let us take it as delta x is equal to 1 meter. Let us assume as it. Okay. So for this, what happens? So this will be when I is equal to 1. So that will be u2 to the power of 1 minus 2u of I, sorry, 1 to the power of 1 plus u of 0. So basically, the meaning of u of 0 is nothing but, so it is corresponding to the walls. So if we have any values or if we have anything on the wall conditions, so that will be this velocity to the power of n. Okay. So this is what we have. So if we observe here, so what we have, so power 1. So whatever the powers we have 1, so basically they are the initial values. So the initial values will be known from the initial condition itself. So the power 2 indicates, so this is for the final value or the next value or the unknown value. So this value we will get, so when we calculate these equation, let's say this is 3 through arithmetic operations. So here what do we have in explicit method? We have only one unknown and remaining all are the known parameters. Okay. So this is what we have for the explicit method. So let us take for the implicit method. Okay. So let us do it for implicit method. So again, let us take the equation dou u by dou t plus alpha dou square u by dou x square is equal to 0. So the implicit method, so what do we have? U of I to the power of n plus 1 minus u of I to the power of n divided by delta t plus alpha. So this will be u of I plus 1 to the power of n plus 1 actually. Okay. Minus 2 u of I to the power of n plus 1 plus u of I minus 1 to the power of n plus 1. So divided by delta x square is equal to 0. So here you can see clearly that let us write again here the explicit equation. So let us compare. So what we have written in the previous slide, 30 plus alpha u of I plus 1 to the power of n minus 2 u of I to the power of n plus u of I minus 1 to the power of n divided by delta x square is equal to 0. Okay. So here what we have, so let us compare this equation. Here let us take it as 4 and this as, let us take this as 5. Okay. So if you compare 4 and 5, so what do we have here? So these terms are equal, first terms. Okay. But when this is basically, this term is a time derivative term. Okay. So the time derivative term, so whether it is implicit scheme or explicit scheme, it is same. But when it is coming to the space derivative term, so what do we have? So in the space derivative term, so the index, so the subscripts are same. You can see here. You can see the subscripts are same. What about superscripts? So superscripts are different actually. Superscripts in the sense the times. So the time level. So basically here for explicit method. So the fifth equation, so which we are talking, so it is of explicit method. So in the explicit method, so this term is having all the variables, so which are known parameters. But whereas for implicit method, so these terms u of I plus 1 to the power of n plus 1, u of I to the power of n plus 1, u of I minus 1 to the power of n plus 1. So these terms are basically, they are unknown terms. So when we compare equation 4 and 5, so what do we have? So in the equation 4, so we have only one unknown parameter, which is u of I to the power of, equation 4, we have only one known parameter, which is u of I to the power of n plus 1. And in the equation 5, we have only one unknown parameter, which is u of I to the power of n plus 1. Okay, so this is the difference. So equation 4, equation 5, the major difference is in the equation 4 we have only one one known parameter. Okay, in the equation 4. In the equation 5 we have only one unknown parameter. Okay, so the number of variables here, so 1, 2, 3. So the number of unknown parameters will be 3 here. Okay, and the number of unknown parameters here, it will be 1. So that is the difference actually. Okay, now so the explicit method is very straightforward and it is simple and easy to solve, whereas for implicit method it is very difficult. Why? Because so we have more unknown parameters compared to known parameters. Now, so how do we solve actually? So the basic difference here we can see clearly, but the solving implicit methods, they are not straightforward. Why? Because we have more unknowns. But solving explicit methods, they are very straightforward. Why? Because they have only one unknown and remaining all the known values. So how do we solve? So basically there are numerous techniques. So in that now we will be seeing, so what is ADI technique? So alternating direction implicit method. We will consider again both the explicit and implicit method. So in the ADI technique, so we will see what is ADI clear. So ADI, so alternating direction implicit method. So let us consider the same equation, so which is dou u by dou t plus alpha dou square u by dou x square is equal to 0. The same equation. Now we will split actually the ADI technique into two steps actually. Okay, so let us take the time step t1 is equal to 0. Okay, and t2 is equal to 1 second. So this is what we have. So t1 is equal to 0, t2. But here let us take it as in terms of n. So let's say t1 is equal to n seconds. So t2 is equal to n plus 1. Okay, so here what do we have? So delta t will be equal to t2 minus t1. So which will be of 1 second. So which is n plus 1 minus n. So which will be of 1 second. So this is of delta t. Okay. Now, so here instead of taking delta t as 1 second, so we will split the time levels into two equal halves or two ways. Okay. So one, let us take, so t1 is equal to n and ti intermediate. So it will be n plus half. Okay. So this is of first level. Okay. So this is the first level. So the next level, so what do we have? So let us take, so the t1 is equal to n plus half and t2 is equal to n plus 1. So this is of second level. Okay, so in the ADI technique, so alternating direction implicit technique, so what we are doing is, so we are dividing the time level of 1 second, so which is of in between n and n plus 1 into two halves, or we can take it as two levels. So first level and second level. In the first level, so what do we have? T1 is equal to n and ti basically it is called the intermediate level, or you can take it as t2 also again. So instead of ti you can take t2, it's your wish actually. So for our convenience, let us take it as t1 t2. So here also for the second level we can take it as t1 t2. Why? Because already we have written here about the levels. So we will write separately what is first level, so what is the second level, and we will see equations clear. Now what happens in the first level and what happens in the second level, we will be seeing. So in the first level, we will actually take the equations in implicit method, and in the second level, let's say in the first level, what we do is like in the x direction we will take it as implicit method, and so if we take 2d actually, so we will take 2d, so which is additionally dou square e by, so dou y square is equal to 0. So in the ADA technique, so what we do is like initially, so we will take x direction as implicit and y direction as explicit, and next for the next half, the x direction will be explicit and y direction will be implicit. So we will see in detail so what happens in the first level, so we will see in detail what happens in the second level. So let us see so what happens in the first level of ADI method. So what do you mean by first level? So which has T1 is equal to N, so T2 is equal to N plus half. So in the first level what we will do, so x direction will be implicit. So y direction will be explicit. Okay. So in the first level of ADA method, so what we are doing, so we are considering a time step of time level. So basically T1 in between T1 is equal to N, T2 is equal to N plus half. Okay. So in the along x direction we will consider it as implicit, along y direction we will consider as explicit. Okay. So here, so basically T1 is equal to N, T2 is equal to N plus half. So based on that, so we will take this equation dou u by dou t. So basically this equation is 2D diffusion equation. Okay, 2D unsteady diffusion equation, dou u by dou t plus alpha into, so dou square u by dou x square plus dou square u by dou y square is equal to 0. So this is what we have. So let us consider it for the first level. So now what happens actually? So u of I to the power of n plus 1 minus u of I to the power of n divided by, so what will be the time step actually? So it will be delta t by 2. Why? Because t2 minus t1 will be half. You cannot take directly delta t plus alpha into, so what we are taking, x direction implicit, y direction as explicit. So this x direction, so this one we will write in terms of implicit. So how? U of I plus 1 to the power of n plus 1 minus 2 u of I to the power of n plus 1 plus u of I minus 1 to the power of n plus 1 divided by delta x square. So this is first is implicit. Okay. Next plus the y term. What we will do? So u of, so here we have to write I comma j since it is 2D. So we have to write I comma j. J will be constant. So along y direction, so what will be constant? I will be constant. So it will be I comma j plus 1 to the power of n minus 2 u of I comma j to the power of n plus u of I minus 1 comma, sorry, j minus 1 comma I to the power of n divided by delta y square. So here we can see clearly, so what is happening? So this 2D unsteady diffusion. Okay, so this 2D unsteady diffusion equation. So what we are doing basically, so we have taken the time derivative term. So this time derivative term we have divided first into this half. Next the space derivative term. So what is the space derivative term? We have dou square u by dou x square, dou square u by dou y square. So this dou square u by dou x square term, So what we are doing is like, so we are first taking the x direction as implicit, and the second one, so basically the y term, so we are taking it as explicit. Okay, so this is of first level. So in the second level, what happens? In the second level, so of ADI, so the time t1 will be equal to n plus half. So time t2 will be equal to what? N plus 1. So in the previous case, so this will be n plus half. This would be n plus half. This would be n plus half. This would be n plus half. Okay, but because it is between uh, n and n plus half, so here it should be t2 should be n plus half, n plus half, n plus half, n plus half. Okay. So here in the second level of ADI, so what we are doing? So again, we'll consider the same equation right here. So dou u by dou t plus alpha into dou square u by dou x square plus dou square u by dou y square is equal to 0. So here in the second layer of ADI, what we are doing? So the x direction will be which one? Explicit. So y direction will be implicit. Okay. So in the previous first level, what we have done? So first level, the vice versa. So basically, x direction is implicit, so y direction is explicit. Now here x direction is explicit, y direction is implicit. So let us see clearly. So u of I to the power of n plus 1 minus n plus half. Sorry. So this will be n plus 1 minus u of I to the power of n plus half. So this will be, so in the second level, so this term will be the input from the first level. Okay. Divided by delta t by tau. Okay. Plus alpha into, so this is explicit. So u of I plus 1 to the power of n comma j, I comma j minus 2u of I comma j to the power of n plus u of I minus 1 comma j to the power of n divided by delta x square. Okay, so this is x direction explicit plus, now y direction will be implicit. Now how? So u of I comma j plus 1 to the power of n plus 1 minus 2u of I comma j to the power of n plus 1 plus u of I minus 1 j minus 1 comma 1 to the power of n plus 1 divided by delta y square. So is equal to 0. So here in the previous equation, so is equal to 0. This should be, yeah, so this is n plus half, and this here you can see it is n plus half. So the n plus half is the unknown time level, the first. Okay. The second level, so the n plus 1 is the unknown time level. Okay. So here what happens actually? So when we compare the equations, let us take this as 2 for ADI and this is for 1 for ADI. So when we compare the equations 1 and 2 in the ADI method, so what happened actually? So we have taken x direction as implicit, we have taken y direction as explicit. So here the x direction as explicit, y direction as implicit. Now by doing this, what is the advantage we have? So let us write the equations one together. So which is u of I comma j to the power of n plus half minus u of I comma j to the power of n divided by delta t by 2 plus alpha into u of I plus 1 comma j to the power of n plus half minus 2 u of I comma j to the power of n plus half plus u of I minus 1 comma j to the power of n plus half divided by delta x square plus u of I comma j plus 1 to the power of n. Next minus 2u of I comma j to the power of n plus u of I comma j minus 1 to the power of n divided by delta y square. So this is what we have. Okay. So this is what first level. So let us write the second level. U of I comma j to the power of n plus 1 minus u of I comma j to the power of n plus half divided by delta t by 2 plus alpha into, so u of, here it will be I plus 1 comma j to the power of n which is what we have, this is the known value. So this will be the same again, n plus half. So this will be the n plus half. This will be the n plus half. Why? Because this n plus half will be known from here. Okay. So that will be the input here. Plus u of I comma j minus 1 to, sorry, j plus 1 to the power of n plus 1. Okay. Minus 2 u of I comma j to the power of n plus 1 plus, so this is here divided by delta x square plus u of I comma j minus 1 to the power of n plus 1 divided by delta y square equal to 0. This is also equal to 0. So if you see, this is what, entirely second level. So this is the first level and this is the second level. So when you compare first and second level, so what do we understand? So in the first level, so what is happening? So here we have taken the half step where we have the implicit along x direction, explicit along y direction. So whatever the answer or whatever the output we'll get from the first level, so will be is this one. So u of I comma j to the power of n plus half. So will be the input for this. Okay. So will be the input for this case. So where this is of second level. So here the first level, so n plus half is the unknown parameter, n is the known parameter. So similarly actually here, so this n plus half will be the unknown parameter. Okay. So yeah, so by doing this two aspects, so what is the advantage? So what is the advantage? Nothing but, so when we do fully implicit method, so we have more number of unknowns. So when we do one direction implicit, one direction as explicit, so what we'll do is that, so we'll get the values along y direction in half step, and other half step we will get the values along x direction. So this will make a full time step. Okay. So within a one time step or within a full time step, so what we are doing is like we are dividing into two halves. So in the first half we will be calculating the known parameters, or we will calculate the values along y direction, and the second half we will calculate the values along x direction. So which constitutes, so for one time step, so we will get the full values of x direction, full values of y direction. So that is why, so the ADI method is basically dividing into first level and second level. Okay. So here y explicit, So here it will be X explicit, and here it will be X implicit. Here it will be Y implicit. Okay, so by doing this, what is happening? So from this we'll get Y values. So from this we'll get X values. So when we club these two, so we'll get a single delta T, so which is of both X and Y. Okay, so combining the advantages of both first step and second step, so we can solve straightforwardly the 2D unsteady diffusion equation using ADI method. So if we do everything using explicit, so explicit method basically they are conditionally stable. Implicit method they are unconditionally stable. So basically people prefer for implicit method by because the stability is unconditionally. So and the problem with implicit is they are not straightforward to solve. Therefore, what we are doing is like we are dividing into half, and when we are dividing into half will be explicit, half will be implicit, and we'll combine them and we'll get a single value of delta T for the unsteady diffusion equation, which is of 2D. Okay, so hope this is clear. So in the next session, so we will we'll go for the other time levels, and we will see the other numerical schemes and how they are varying when we compare it to the ADI method. So the next will be the McCormick scheme, and we have seen Frank-Nichols scheme already, so which is of second order implicit method. So we have taken a general equation. So we have given a switching factor theta. So when theta is equal to 0, that will be of fully explicit. When theta is equal to 1, it will be fully implicit. When theta is equal to half, that will be semi-implicit, which is called Crank-Nicholson scheme. So in today's session, so we have seen the ADI method, so which is called alternating direction method. So which is of two-step solving method. So which is of explicit combination of explicit and implicit. So which constitute to a single time step giving the unknown values with the known values. And it is somewhat lengthy process, but we can clearly get the values with the long process. But when we do fully implicit, we cannot get it actually. So when we divide into two equal levels, so first level will get y values, the second level will get the x values. There, when you club those two levels, we'll get overall all the values. Okay, so this is what the advantage or the advantages of the ADI method. Okay, so in the next session we will be seeing other numerical techniques. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.